All right, so here is your short lesson that I told you I would give you on simplifying radicals. There are really two ways to simplify radicals. You can make a prime factorization tree, but the easiest way, I believe, is to use perfect squares. So that's what we're going to do today. We're going to just factor using perfect squares. So example A, I have the square root of 28. Well, I know that the square root of 28 is the same thing as the square root of 4 times the square root of 7. 4 is a perfect square. The square root of 4 is 2. So I have 2 times the square root of 7. Okay? The second example, I have the square root of 216 k squared. So I'm going to break this up first of all as the square root of 216 times the square root of k squared. This is probably one of the first examples that we've done that has a variable inside of it. Let's see, I know 216 is definitely divisible by 4, so let's just try that. So 216 divided by 4, that's the same thing as the square root of 4 times the square root of 54, and then I have the square root of k squared. Okay? Well, the first thing I'm going to do is take that k squared out. I know that that's k, and I know that this is 2. I just need to focus on the square root of 54. Well, I can rewrite that as the square root of 9 times the square root of 6. So now I have another perfect square. So now I have 2 times k times 3 root 6. Well, 2k times 3 is 6k root 6. And I'm just trying to show you each step along the way. I'm sure some of you can do this in your head. I'm just trying to show you step by step, okay? Example C, I have a negative 3 on the outside, so whatever I get, my final answer is going to be multiplied by negative 3. So under the radical, I have the square root of 720 divided, or sorry, under the radical, I have the square root of 720 p cubed. Now, p cubed, that's the same thing as the square root of p squared times the square root of p, okay? That's my perfect square, p squared. And then 720, well, I know that that's 9 times 80. The square root of 9 times the square root of 80, okay? So I'm going to get rid of this p squared. That becomes a p. So now I have negative 3p, radical p. I know that the square root of 9 is 3. So I'm going to just take 3 times 3, so I have a negative 9p. That gets rid of that. I have to do something with the square root of 80. So I have p and 80 under the radicals. P and 80 under the radicals. The square root of 80 is the same thing as the square root of 16 and the square root of 5. 16 is another perfect square. That's a 4. So I have negative 9 times 4, which is negative 36p. And then underneath the radical, I'm going to have 5p. Okay? So here is this one simplified. All right? Okay, let's do 3 more examples. Okay, so remember when we have a fraction, whenever we have a fraction underneath the radical, we can rewrite that as the square root of something divided by the square root of something else. So this is the same thing as the square root of 140 divided by the square root of 65. And again, I just want to look for some square roots in here, some perfect squares if I can. I'm going to go ahead and divide this up as the square root of 7 times the square root of 20. And I know that the square root of 20 is the same thing as the square root of 4 times the square root of 5. So I actually have the square root of 7, square root of 4, square root of 5 in my numerator. My denominator, I know it's divisible by 5 for sure because it ends in 5. So I know it's 5 over 13. So the denominator looks like the square root of 5 times the square root of 13. Now hopefully you remember from class that we've actually simplified this, right? I can just cancel both of those out. I know that the square root of 4 is 2, so I'm going to get rid of that. So I really have 2 radical 7 over radical 13. The only problem is that we don't want to leave a radical in the denominator. So I'm going to have to rationalize the denominator by multiplying both top and bottom by the square root of 13. Okay, so when I do that, I need to figure out what 7 times 13 is. That's 91. So I have 2 times the square root of 91 over 13. Okay, and that is this answer simplified. Okay, I have 2 more examples. I have the square root of 32 minus the square root of 8. I'm going to rewrite the square root of 32 as the square root of 16 times the square root of 2 minus, and I'm going to rewrite the square root of 8 as the square root of 4 times the square root of 2. All right, the square root of 16 is 4, so I have 4 root 2 minus 2 root 2. All right, since the radical, the number underneath the radical is the same, since these are identical radicals, I can combine those like terms. So I actually have 4 radical 2 minus 2 radical 2 equals 2 root 2. Okay, I have one more example for you. This one is interesting. We have not done this at all yet. This is actually using the distributive property. We're actually going to distribute radicals. So I have the square root of 3 times the quantity 4 radical 12 plus 2 radical 6. So I'm going to distribute that square root of 3. So the first thing that I'll do is rewrite these, kind of breaking it down. So I have the square root of 3 times 4 root 12 plus the square root of 3 times 2 root 6. Okay, so square root of 3 times the square root of 12, that gives me 4 the square root of 36 plus the square root of 3 times the square root of 6 gives me 2 root 18. Now again, I want to try and simplify these radicals, so I'm going to look for perfect squares. Well, the cool thing is that the square root of 36 is already a perfect square, so this becomes 4 times 6, okay, which is 24. And then here, 2 root 18, well my square root of 18 I can break down to square root of 9, square root of 2. I know that the square root of 9 is actually 3, so I'm going to multiply 2 times 3, and I'm going to get plus 6 root 2. So rewriting this, I have 24 plus 6 root 2. Now remember, this radical is very similar to a variable, okay? If I don't have the same radical on both terms, I can't combine them. So this is as simplified as my answer is going to get, okay? So if you were asked to simplify radicals, leaving your answer in simplest radical form, that's perfect. That would be acceptable, okay? So good luck.